All right, so the next thing that we're going to do is the coefficient of variation, and this it's called CVAR. So it's written CVAR. This is a statistic that allows someone to compare standard deviations when the units are maybe different. So let's say in our class I wanted to know which was more variable out of our students, their height or their weight. So I would find the standard deviation for both, and we would do the CVAR and determine which was more variable, the height or the weight. So which measurement had more variation in it. Height would be in feet and weight would be in pounds. You couldn't normally compare those two things, but we can compare the variation this way using the CVAR. So this thing answers questions: which set of data is more variable? And so we're going to do this example. Ages of accountants. Oh, I should give you the formula. Sorry, guys. So CVAR is equal to the sample standard deviation divided by the sample mean times 100%. It's always written as a percentage. And this is for sample. If you had population, you would, of course, do a CVAR using the population standard deviation and the population mean times 100. You could do it with either populations or samples. So we're going to do this problem up here. It says the average age of accountants at Three Rivers Corporation is 26 years with a standard deviation of 6 years. So we're going to, it doesn't matter whether we're talking about population or sample, they're done the same way. And then it says the average salary of the accountants is $31,000 with a standard deviation of $4,000. Compare the variation of age and income. So this is the same idea. Which set of data is more variable? Is the same question that they're asking when they say compare the variation of age and income. So the only way to compare these two is to use a CVAR because they're different measurements. So let's do CVAR for age. And so that's going to be the standard deviation, which is 6, divided by the mean, which is 26, and we're going to multiply by 100%. So if we do that, 6 divided by 26 times 100, we get 23 point, and if I go one decimal place, 23.1%. Okay. And now we're going to do the same thing for salary. We're going to find the CVAR for salary. And so that again is the standard deviation, which is 4,000, divided by the mean, which is 31,000, times 100% to get a percentage. So 4,000 divided by 31,000 times 100 gives me 12.9%. So the age is a bigger number. The CVAR for age is bigger than the CVAR for salary, so the age is more variable. Right? Because it has a bigger value. All right. So there's more variability in the age than there is in the salary. The next thing that we want to cover right now is what's called the range rule of thumb. Whoops. So the rule of thumb for standard deviation is what it's really called. Rule of thumb for standard deviation. And so this rule of thumb for standard deviation uses the range, and it says approximately really rough estimate of a standard deviation of a population is going to be the range divided by 4. So if we look at, sorry, something just went through my mind. So if we look at, let's find a data set that we can look at. So we'd have to actually have the full data set. So here's the data set for hardcover bestsellers, and we want to look at an approximation for the standard deviation. Then the range, remember, is the smallest value or the biggest value minus the smallest value. And we found the range here, and it was 17. Okay, so if we did 17 for this rule of thumb, we did 17 divided by 4, we would get 4.25. And so that's a rough estimate of the standard deviation. If you just got to kind of approximate the standard deviation, you don't want to find it exactly, this is a quick way of doing it. But it's not a great way. So let's look at that rough estimate here. And we did find the standard deviation in this problem. So this problem's standard deviation was 4.24. Yeah, that was pretty good. I'm pretty surprised how close that is. So it did a really good job on this case of finding the standard deviation. And it doesn't always do such a good job. But it is a rough estimate for the standard deviation. All right, so those are the two things that I wanted to talk about at the moment. The next thing that we're going to do is talk about Chebyshev's theorem and empirical normal form. So those are the last two topics in this section.